So I'd just like to welcome you to today's session on noise and hand-on vibration. There are three papers which are hopefully going to give us a very broad broad insight into some of the noise and vibration issues in the real world. So I'm going to start off with Peter Wilson. I love the title of yours, and I'm intrigued to know how we head towards a nil noise-induced hearing loss world, so fingers crossed. For those who don't know Peter, he's Technical Director of INVC, member of the Institute of Acoustics, and I assume you've said this yourself, you're a popular speaker at conferences.
I get invited, so
he is a popular speaker. For anybody who's heard him, he's fantastic, and I've realised today that apparently he does stand-up comedy as a hobby, which probably helps. So he wrote the IOSH competency courses in both noise and hand-on vibration, has a reputation for developing innovative engineering noise and vibration control techniques, and he's also been involved in mental health campaigns at conferences, in schools and on national TV. So if we welcome Peter now to talk to us about our approach towards a nil noise.
Thank you very much. Welcome. Good afternoon, post-lunch dip, no doubt. I'm going to be just talking about the gold-plated elephants in the noise risk reduction rooms. Unfortunately, most hearing conservation programs, risk reduction programs, are inadequate. And it's very depressing, and I've been doing this for a very long time, and it's time it changed. So I'm going to be talking about the practicalities. The problem you've got is how do you persuade people to change what they do? And unfortunately, a lot of the assumptions that hearing conservation programs are based on are false. At the moment, there's good news and there's bad news. The bad news is PPE doesn't work very well, and also very bad news is that there's recently been over 700K hearing damage claim, and the legal framework has also changed so that claims are going to start going through the roof. And so it's time to get a grip on it early. So the good news is that you can reduce hearing damage probably by around about 80 or 90% within current budgets, just by changing what's done and updating to current best practice. So the key elements are hearing protection. The reality is you're more likely to be getting 5 to 10 dB rather than the 20 to 30 dB that the manufacturers tell you. That's the reality. Secondly, audiometry. Pure-toned audiometry is a placebo exercise, not much use to man or beast. It tells you about things far too late. Switch to OAE, and I'll talk about that very briefly. Risk assessments. We run the IOSH competency training courses. We see a lot of reports, most of them are useless, and the HSE confirms that 2/3 of risk assessment reports are inadequate. And you should be using a template report. Noise control has never been considered. This is really bad news because there's a fallacious argument that unless you can get below 85 or 80, there's no point in doing noise control. That's not true. And finally, why does no one ever work out the return on investment for what they're spending compared with the risk reduction they're getting? Has anyone here done a return on investment exercise calculation for what you're doing as far as risk reduction is concerned in noise? A unanimous no. Why? You know, the accountants in your companies need to know that sort of information. So very quickly, over 700K claim recently in 2023. This is going to have a massive knock-on effect on future claim values, and this also has a big impact on insurance costs, because insurance companies are going to look at this and going, we're talking to insurance companies at the moment. It's scary, the amount of, current claims, what, 5 to 10K? If you're looking at 500,000 to 750,000, that's a whole different game. And yeah, the claims lawyers are all rubbing their hands and going, well, that's my new Ferrari taken care of. And to give you a context of that, in the States, 3M have settled a claim for £4.5 billion. 4.5 billion with a B. And currently in the UK, the same thing is happening against 3M. Thousands of British veterans are doing the same thing. This is like the canary in the mine. It's happening now. Claims are going to go through the roof. The other thing is new research about the damage caused by noise-induced hearing loss. Noise-induced hearing loss is the #1 modifiable risk of dementia that there is. And we have a tidal wave of dementia. Both my parents died of dementia. My dad died of dementia, probably caused by, he was in the army, he had hearing loss, probably caused by that. Plus, not only that, you've got 5 times the risk of dementia. If you've got serious hearing loss, you've got 5 times the risk of dementia. Not only that, but there's a massive increased risk of Parkinson's, and it doubles your risk of having an accident and higher unemployment likelihood and so on. So these are health effects. And the result of that is because the new legal framework says we're looking at health effects, not just pure-toned audiometry. We're looking at the effect on your health forever. Are you going to get dementia? You've got dementia. Okay, big claim. And people can also claim for levels below 85, whereas previously they couldn't. Huge change. So PPE. It's been known about since, this is 1996 data. These are in red, you have the actual field performance for several different types of earplug, and in yellow you have the theoretical performance provided by the supplier. There's a huge difference. We're talking about 2 to 10 dB from earplugs, not the 15 to 30 dB claimed. And if you look at earmuffs, it's similar, not quite as bad, 10 to 15 dB, not the 20 to 30 dB. And the result of that is that up to around, the rule of thumb is up to around 90 dBA, you've got a good chance of your hearing protection being adequate. Above 90, it is very difficult to prove it's working properly. And above 95, it's getting pretty well impossible. So that's the reality. This has been known about for years. And we've recently produced what we call a real-world PPE performance calculator. You can download it. And what it does, it allows you to fill in some simple questions based on the latest of current technology from the HSE and from our own research and from other bodies. Basically, on this particular one, I don't know if you can see that in detail, the manufacturer's data for muffs, plugs, and custom molded is 25 dB attenuation. By feeding in the wear rate, how many of you measure the wear rate in noise hazard zones? Not guess, not say it's about, not saying it should be 100%. What is it actually? If you don't know, you have no idea of the protection being afforded. So if you feed in that and also things about safety glasses, safety goggles, other safety kit, masks and so on, and fit testing, in this particular case with 80% wear rate, we're talking about 5 to 6 dB attenuation for each of those. So you can download that and use it to give yourself an idea of what you're actually likely to be achieving with your hearing protection, not the figure you think you are. This has been known about for decades, and yet people do not use this information. So that's why we've issued this calculator for you. Why have current practices failed in terms of audiometry? I've said that pure tone audiometry is a placebo checkbox exercise. And when it came out, the HSE regulations, I was on the road shows launching the regulations, and the quote I like is that audiometry is a tax on the failure to control risk. It's not a risk management tool, it's a tax. And the problem is outer hair cells. You can have 30 to 50% of your outer hair cells in the cochlea killed off before you can detect it with pure tone audiometry. Pure tone audiometry is subjective. It tells you 10 years down the line, when it's too late, you have got bad hearing. And it's caused by noise at work. It's useless as a tool to reduce risk. And it also doesn't pick up all forms of hearing damage either. So here's an example. This is from Rob Shepherd, who's an expert in the field in the UK. These are 6 pure tone audiograms. They all look normal. 3 of those people have severe hearing damage. Look at the pure tone one, those are the 3. That are normal, those are the 3 that have got damage. And it's obvious. With pure tone audio, with otoacoustic emission has been around for decades. It was used on children in the 70s because you can't ask a child, can you hear that tone? It's a no-brainer. You can do it in a quiet office in 10 minutes with a day's training. It's a no-brainer, and it tells you, last year you had 12% damage to your hair cells, this year you've got 18%. We need to do something about it. So it's actually a risk management tool. So if you compare it with pure tone audiometry, it detects the early signs, whereas pure tone doesn't. It's easily understood. no decibels and so on. Motivational aid, last year you had this damage, now it's worse. Objective evaluation, it's not subjective. The person who's being tested has to do nothing, they just sit there. And no specialist booths required, and they both meet the requirements of the regulations. So it is a no-brainer, and at some point there'll be a court case that says the date of guilty knowledge, you should have known that OA used best practice from January 2027, January 2026. The court will decide when it should have been more general enough knowledge that you should have used it. It's a no-brainer. So, noise reports. Most of these are placebo, not photocopy, that's so old-fashioned, I mean copy and paste, exercises. As I say, we see loads and loads of reports because we run the Irish competency training course, and we completely agree with the HSC have done a recent survey on report quality, 60% inadequate. In 2002, 63% inadequate. Nothing has changed in over 20 years. Report quality is awful. The key thing you need to do, as far as reports go, and very simple, is invest in a template that is high quality and has got everything in it in terms of best practice. And whether you do your risk assessments in-house or use a consultant, you make sure they use the same document format. Because I've looked at like 20 or 30 years worth of noise assessment reports every 2 or 3 years. And they're all completely different. Some of them are 3 pages, some of them are 3 inches thick. You cannot work out how you're doing if every report is completely different, done by someone else in a different way. You have to formalize that and get a template. Noise control. This is another very big source of mythology. Most people think that unless you can get noise below 80 or 85, there's no point in doing noise control. Well, that's not true. And why is the hierarchy of control completely upside down in noise? PPEs, number 1, and number 2, and number 3, and number 4. And noise control, it's right at the bottom and very rarely considered. So the traditional approach to noise control, unfortunately, and I blame most consultants for this, most consultants have abysmal knowledge of modern noise control engineering, treat everything as a black box, and the only solution is to add another black box. Or they just don't diagnose the problem. So
apparently, this is not a machine, it's a black box. This black box radiates high levels of noise, so the only solution is to fit another box. If there's no diagnosis, then all machines are black boxes.
So if you're looking at noise control, if you're a manufacturer of enclosures and silencers and the like, then if you make hammers, every problem's a nail. This is a sort of analogy for this that most people can probably feel is adequate. It is, you have your car, there's a rattle from the engine. So you take it to a garage, and without opening the bonnet, they say, you need a new engine. If you open the bonnet and do the diagnosis, it's a loose bolt on the heat shield around the exhaust. So you put a new bolt in, problem solved. This is what happens in noise. People do not ever look at why it's noisy and can I fix that. If you do that, in a massive proportion of cases, there are simple, low-cost solutions. Now, bigger misunderstanding, noise risk is directly proportional to noise energy. So every time you reduce the noise by 3 dB, you've halved the energy, which means you've halved the risk. So if you cut the noise from 100 to 97, you have halved the risk, even though PPE is still required. 6 dB off means you've reduced the risk by 75%. So if you knock it down from 95 to 89, you've reduced the risk by 75%, even though hearing protection is still required. But at least now your hearing protection is adequate. So, and as I've said, knowledge of modern noise control engineering from consultants is abysmal, truly abysmal. There's virtually nobody does any diagnosis. It's so simplistic, and the HSC report, I think 77% of noise assessment, risk assessment, and noise risk reduction reports contain nothing whatsoever about noise control, which is just incompetence. So what you need to do is to do an evaluation of what your noise control options are. And if you do that, you can work out the costs and the benefits. We do a lot of these, a lot of them remotely. by email, because we have a huge, huge database of noise control solutions. And you use that information to plan a noise control program. And from that, you can work out this. On the y-axis, we have cost. On the x-axis, we have years. And what we've got here is the noise control cost is in dark blue. So if you add in the maintenance cost for noise control technology, in green, you have a very slowly increasing slope above 30 grand. Whereas the PPE is the same every year. The costs of PPE just keep going up and up and up. So in this case, after 2.5 years, you know it's break-even point from cost savings and PPE. And also, you need this information to decide what is the best thing to do. If there's a very low-cost, cheap solution to your noise problem, let's take sellotape. Sellotape can be incredibly noisy. If you have carton machine putting wide tape onto boxes, well over 100 dBA. Now, a company bought 3 of these machines, 100 dBA, oh dear. So they went to the supplier, and who said, well, we're selling 25 grand's worth of enclosure per machine. What we did, we said, okay, there's an alternative. Quiet tape. Now, I may be sad, but I think that's cool. Maybe I should get out more. Here's another one. As an engineer, I love this material. It's laminated steel, which is very highly damped, looks like steel, behaves like steel. It's hygienic and rugged, but sounds like rubber. So if you know what's possible, if you knew what was possible, what would you do? It's like air, compressed air. Compressed air, you can buy off-the-shelf nozzles for the same duty, use 20% less compressed air and a 90% reduction in risk. You'd do it even if noise wasn't a problem, if you knew what was possible, and also for purchasing policies as well. So top 10 noise control solutions you can download off our website. These are common solutions to common problems. And the other thing is that if you do the diagnosis and do engineering noise control, it's also extremely green, because things like enclosures and silencers and things, they use a lot of materials and not easily recycled materials in a lot of cases. So you're using a fraction of the materials, and we do probably now 50% of our noise control projects across the globe remotely by email. That saves an immense amount of time and money, and also travel costs and carbon and so on. And take fan efficiency, using aerodynamic noise control, companies are saving megawatts of power around the planet from what we've recommended them to do, because it uses less energy to run than using silencers. And here's an example of that. This is, you've probably lain awake at night wondering, how do they pull damaged aluminium drinks cans off the production line? Or maybe that's just me. 3 systems, you can see the stacks there. They were quoted 35 grand. It was an environmental and an occupational noise problem. The cans pass through the fans where they are shredded for recycling. If you can play the sound, please. So instead of 35 grand per system, it cost them 3 grand to do all 3 fans. And that's a modified fan. It looks exactly the same as an unmodified fan, and 22 dBA reduction. If you knew what was possible, what would you do? And say, we do this all around the world. Remote control, I'm doing a major noise control project, occupational noise control project for a hygiene company with sites all across the globe, all done by email. And we're talking about 10 to 15 dB noise reductions, cutting the noise from their plant down to below 80, and from their over 100 level, we're down to below 90. So this is all technically feasible these days. So if you knew what was possible, what would you do? And everywhere. So finally, return on investment. Nobody does this, and I don't understand why, because you're spending money, so you need to know, am I spending the money wisely? So looking at return on investment, actual PPE performance. Okay, so I go to site and looking at their, you look around and you go, the wear rate's about 50%. So on average, you're getting 3 dB off, and you're spending 10 grand a year on hearing protection in this environment. Is that a good deal? No, it isn't. It's putting figures to it, putting financial figures to the risk, and then working out how best to spend your resources. So what's the actual daily wear rate? You need to know that. You need to assess that. You either have to regularly do a quick evaluation using a supervisor or somebody, otherwise you have no idea what protection is being afforded. There is another option these days, which is what I call intelligent PPE, which is linked, headsets or headphones that are both PPE and also they log the noise that's going into your ears. So you can actually, it's like a personal dosimeter that you're wearing all the time. It's also hearing protection. And that tells you at the end of the day what the exposure of that operator was. But you need to know realistically what the wear rate is and what the PP performance is likely to be. Or you can use that calculator that you can download and get a good idea of it and do what ifs. What if I improve this or do that? What effect would it have? Noise assessment and health surveillance. You need to have a template high quality report, period. And also you need to switch to OAE. Both of those things at the moment are often placebo. I read all these noise reports. I don't care if the noise consultant's got O-level woodwork and pages and pages of stuff copied off the HSE website. This is not what it's for. It should be a 1 to 2 page document lifted out of the main report, which you can put on the desk of a maintenance engineer and you don't scare him. This is what you need to do by when, who's responsible to improve things. And on noise control, has anyone ever carried out an evaluation of the noise control options with costs and benefits? It's a requirement of the regulations. You are not allowed to use PPE as a long-term risk control measure unless you can prove you can't get rid of the risk. This is part of the problem, the fact that hierarchy of control is upside down. Everyone goes, oh, we've issued PPE, problem solved. You haven't. And with 500,000, 750,000 hearing damage claims coming down the pipeline, you need to think about these things. You need to change things. So it's working out what the return on investment is likely to be from what you're doing. So to make it more effective, summarizing, first of all, noise-induced hearing loss is a massively bigger risk than we ever thought. Dementia, Parkinson's, doubling risk of accidents, employment, and so on. Plus, PP does not work nearly as well as assumed by almost everybody. In the regulations, it says derate your PPE by 4 dB for real-world conditions. No. Derate your PPE to between 5 and 10 dB unless you can prove otherwise. Period. And the HSE noise inspection focus is proving all these things. They bought out reports saying, 60% of reports inadequate, 77% noise reports contain nothing on noise control, PPE is not being managed well, so many people don't wear it or don't wear it properly or aren't getting adequate protection. They've got the data to prove all this. So it's not apocryphal, it's real. And can you imagine standing in court in a couple of years' time? When is the data guilt of knowledge when you should have changed to OAE? So health costs and damage claims are going to go through the roof, and this has big impact on insurance. We're talking with insurance companies at the moment who are getting scared about this because, if suddenly claims are going to go up by an order of magnitude or two, they're going to have to get their money back. So this is going to impinge on you. But if you implement best practice on all these things, you can dramatically reduce the risk. And we reckon just quite easily 75 to 90% reduction in risk within your current budget just by changing what you do and updating to best practice. And noise control is a significant part of that. I mean, obviously, I'm an engineer, so this is my thing. Engineering noise control, that's where I get my kicks, is solving problems like that. But the key thing is to use a diagnostic approach. So you understand why it's noisy and is there a simple engineering fix? And I say we do this remotely now, probably 50% of our projects are remote. In other words, we don't need a site visit because we've seen it before. So it's time to change. This has been going on for years. People are getting unnecessary hearing damage. They're getting dementia, they're getting Parkinson, they're getting all these other things. They're getting social isolation because they've got hearing damage. And a lot of this is just based on poor assumptions, on the wrong assumptions. And some of this information has been available for so long, for years and years and years. And it's about time that people start to use this information. And at the moment, it's quite scary because of the change in the legal framework and the size of the claims. So there's a financial cliff coming in the very near future. Any questions?
Is there a microphone? Got one at the back.
I have a question regarding the calculator you developed.
Yes.
How does it work? Does it also use the octave band analysis?
No, it doesn't use the octave band analysis. Octave band analysis for hearing protection is largely irrelevant because, in theory, if you've got a low frequency dominated noise source, dBA dominated by lower frequencies, you choose different hearing protection compared with hearing protection for higher frequency noise sources. And we always recommend that you do that number anyway to choose the best type of protector. But then you feed that into the calculator, because the reality is wear rate is the number one issue, but also things like fit testing, things like wearing another kit, which is different for earmuffs and earplugs and so on. You could do that calculation, but after that you feed into the calculator and it will tell you approximately what sort of attenuation you're likely to get in the real world. And you can play with it. What if I do this? Oh, that's better. What if I do that? Didn't make any effects. I don't need to worry about that.
Thank you.
Any other questions?
Hello. In light of the comment that you made about ear protectors, only protecting sort of 5 to 10 or a lot less than what's advertised.
Yes.
Is there anything being done by, for example, the British standards that manufacturers are using to actually mark the protectors?
Standards are a difficult thing because they have to be repeatable. And to be honest, if you're testing earmuffs and you're a manufacturer, you want to get the best result you can. So whatever standard you write, they will do their best to get the maximum out of it. So if I was making earmuffs, I would have only bald men tested because the way you test earmuffs, you stick them in an anechoic chamber and then you play noise. So what I would do is I would have only bald men, no hair, no glasses, no nothing. And I would make sure they were very, very carefully fitted and freshly shaved beforehand and so on. Whatever you do, manufacturers are going to try and get the best out of it. It's really, the thing is about wear rate, for example, is not to do with the performance of the earmuff. It's just the fact that you take them off, you lose your protection. So things like that, and also fit testing. I've sat there and seen someone come in with 3 dB from their plugs. They leave with 23 dB. But will they still have 23 dB in 3 months' time when the training is worn off? There's no easy answers to PPE.
Just had a question about impact noise from weapons, like in the military and
Yes.
police services. I know it's terrible, but my husband and my son both are exposed to impact noise from that as a profession. Yeah. And of course they wear double hearing protection, which I'm sure is not that effective.
It's more effective than single hearing protection, but it's not as effective as people might think.
Exactly, and I understand, which I'm not sure is correct, that impact noise is particularly harmful for people's hearing.
It depends on the level. It's just level dependent. It's a pressure pulse. Big enough pressure pulse will rupture your eardrum or do instant damage. So it is, yeah. I've tested munitions. I've measured peak noise of 167 dB. I was nowhere near it. I was on the end of a 50-meter extension cable wearing double hearing protection in another building. I wasn't going to go anywhere near that. And yeah, it's a problem.
Yeah.
And there's no easy solution.
Well, okay. That was my question.
Sorry.
Yeah,
Sorry. I am available for children's parties, by the way.
Oh, thank you.
We just have one last question before we move on.
And I will be floating about at coffee time afterwards, after this session as well.
Sure. Oh, thank you. You mentioned quite a few times that you encourage everyone to have an outline for a report. What types of things are you specifically looking out for in that report that typically you don't see?
I would say, practical advice on risk reduction. Because most reports just have loads of noise measurements, and then they would have a plan that goes, these need to be noise hazard zones, and a load of copy and paste stuff on the HSC website, and loads of stuff about calibration. It's the objective of that report is to say, this is what you need to do over the next 2 years to reduce risk. And in that report, it should be structured in such a way that anyone can read it and understand what's going on. And what we tend to do is we put all the technical jargon and stuff at the back in an appendix, which explains why that's the recommendation. So the safety officer can read that. But the key thing is you need to extract that and put it on a desk of somebody who's got to act on it. And that person won't be necessarily the safety officer. It'll be a maintenance manager or someone like that. So it's got to be, it's not there to show how clever you are as a noise consultant, that you understand decibels, so you've got a brain the size of a planet. It's there to say, these are the simple technical things, like the things I've been talking about. These all sorts should be included in that report.
Can I just add a pointer from HSC on that, which I know is not appropriate, is we also want the reports to actually have an assessment of individuals or groups of workers' exposure, not machinery exposure. So one of the biggest issues we're seeing at the moment is an LEPD that is not related to a worker. If you don't have an idea of a worker's exposure assessment, nothing else, whether you've got your action plan, your controls, nothing else makes sense. So for any consultants, you've got to get your exposure of your people, and that means talking to the person you're doing the job with. I
completely agree, and it's becoming more important because with the changes in not regulations, but changes in legal stuff and claims, it's more down to the individual. What exposure does that individual have? And when you group them, you can say, this department, there's a problem, or there's not a problem. And then you use that as a basis for deciding what to do to reduce the risks.
Okay, can I just hold, we might have a bit of time at the end because we've got a recorded, the last paper is a recorded session. I think we might have about 5-10 minutes at the end if you're happy to wait. Is that all right? Okay, thank you, Peter. Can we show appreciation?